So first of all, thank you all to be here. Today we are going to recap our last talk from Qubika, that is Agentic AI in Finance and how to build agents using Databricks and LangGraph. For the people that don't know me, I'm Sebastián Diaz, have 15 years of experience working on IT and more than 10 years of experience working on the data area. Here on Qubika, we have an expertise with multiple clients working with Disney, The Local, Pluralsight, Harvard, and we are select partners tier with Databricks and AWS. So today the idea is to talk about AI. As you know, AI is growing really fast for all in the market. I think we are moving out from this POC phase and we are starting to face the problems of the POCs, those problems that are more product related that we are always avoiding on the POC. And when we start facing that situation, we start feeling that what more of our clients, especially on the finance area, use AI is to retrieve information, right? To take information from different places, from different sources. Let's think about a database, an Excel file, a Google Drive instance, images, audios, and so on. We are facing that the solutions that were right now on the market, they were hating to tackle files as all content and put an LLM to process it. But when we start using this, we start discovering that it's not so easier, that our data, it's more difficult than actual text that an LLM is able to retrieve to answer questions. And we are facing more diversity and integrations problems that make it difficult to advance to a production level. So talking about this business challenge, we know that in finance, most of the decisions are taken in really small times. And many times the data that is used to take those decisions is divided into multiple silos. Those silos are the biggest barrier to us to be able to implement AI because it's not easier to integrate them, especially for the different type of data that they contain. Not only that, finance is a business where its high regulatory and compliance risk are really intense. So we are constantly checking the PII data, the compliance, the security of that information. Because if not, we are risking using AI and putting in risk all the data that we have. This slow decision taking is taking business for us, is making it difficult to implement AI, and also is creating an IT dependency in where we need to have a highly formed technical team each time we need to get information, either because I want my AI to answer new questions, but also because I need to analyze it and I have no time to start unifying those silos to be able to get it. What Qubika solutions offer is the ability of enhance that velocity, enhance the productivity, break those silos, but without losing traceability of what we are doing. I know AI is really attractive, it's really trending, but we need to always be in mind. We could not create new vulnerabilities. We could not lose what is happening with our data, because if not, we are putting in risk everything that we did until now. So as you see, we have here our left, our integration sources. You know, the data could be structured, semi-structured, unstructured, or you could have data that is contextual to what we are trying to do. So mainly what we do on Qubika, unify all that information into a storage layer inside Databricks, and we divide it between the different ways of using that information. For that, we have a parsing agent, a multi-agent solution actually, that what does is takes each of the inputs, each of the sources and data that I storage on Databricks, and start divided and structure between tables, vector DBs, and knowledge graph. And lastly, we have our layer built on LangGraph that is going to be the one in charge of retrieval that information using the guardrails to protect what type of information enters and so on, to be able to produce it either in Slack, on a mail, or a UI, or whatever we need to use that information that we retrieve. For that reason, we use Databricks because one of the big problems of building this type of solution is not only the diversity of the data sources, is also how you are able to monitor and evaluate this solution. How you're able to see and understand that what you are answering is actually correct and is truthful and is not a feeling or a gut feeling that I think this is working okay. That's not a really good way of building trust on the answers of your AI. And also, you need to have a clear and structured governance layer. Databricks provides Unity Catalog. It's an amazing governance feature that lets you govern everything that lands on Databricks and lets you understand who has access, where the source came from, what is the lineage, what I'm storing, putting descriptions on the information that I have, and so on. So all this makes really scalable the solution, because it's not, as I mentioned, it's not only about the answers of AI, it's about my security, monitoring what is happening, having a good observability, having evaluation metrics that are able to differentiate when something is good or not. And lastly, and I think this is a cool feature that we have in this year of Databricks, we are even able to provision models or fine-tune models to be able to grant it. So we use Databricks as our data foundation layer where we build this expanded AI. You're going to see something really interesting that is obviously the structured tables, right? This is not surprise for any person that works with data. You see the vector DB. This is a type of database that is gaining a lot of impulse since LLMs were released, mainly because they let us save the content of our data as embeds, and we are able to use those embeds and a semantic search to be able to retrieve that information. But you are going to see a new challenger here that are knowledge graph. So as you see, we have in our left all the different sources that we have, right? You could have spreadsheets, documents, PDF, emails, another application database, or images. So what we see is that we take all those sources and we ingest it using the feature of Lakeflow of Databricks into a bronze layer. This bronze layer is a common way of putting data in a medallion architecture, and what is going to make us is going to be easier for us to keep processing in the different layers, bronze, silver, and gold, the information when we are adding more value and cleansing the information, right? So we put everything on the bronze layer in our raw ingestion, and when I say everything, I'm talking about saving there the content of a CSV, but also, for example, saving an image or video or whatever I want to save. Databricks offer you what it's called volumes that lets you store raw documents or raw images or raw videos without any problem. After that, we trigger our parsing agent. So the parsing agent mainly what does, it has two functionalities. First of all, start classifying each one of the documents that lands on bronze. And why is that? Well, because let's say that we are parsing a PDF. So you will say, okay, I'm going to parse a PDF. I'm going to use an OCR to read the text and move it into a structured way or send it to a vector DB or whatever. But the reality of our data is that it's more complex than that. Inside a PDF, we could have images, tables, formulas, plain text, reference to other PDFs, and that information, it's not always solved with an OCR. So the parsing agent, what does is takes each one of the documents, classify it on what is the characteristics of those documents, and from there, it's going to use a set of pre-built tools to be able to treat each one of those documents. So let's say we are going back to our example where we were processing a PDF, and my parsing agent detects that this PDF has images and also has plain text. So the parsing agent is going to go and use an OCR to parse in the text, but also maybe could use a BLM to process the images. And the parser agent is going to have three outcomes. The first one is going to be the actual metadata and information of what I'm having on that document. That one, we are going to save it on silver. Also, we are going to save the content into a vector DB. The raw content, for example, of text, we are going to transform it into embeddings and save it on a vector DB. And an image, also we are able to save it on a vector DB. You know, you have collections and chunking and you put everything there. And lastly, something that we keep discovering is that our our data is not only composed by content, it's also composed by relationships. So there is where a knowledge graph, the parsing data, is going to take those relationships, those entity and connection between entities, and it's going to save it on the knowledge graph. This is something that we hit when we were working with a client. We were parsing contracts, state of work contracts that they were having. The main objective was to be able to do a Q&A versus those documents. And we were hitting a wall where if you only use a vector DB, you put all the content of the contracts there and it was okay. And then say, okay, I want to know what is the last contract, what that contract says of client A. But the problem that we discover is many times those type of documents refers or maintain information in other documents. For example, a contract could say, okay, so for the statement of the pricing of the resources, you need to see contract 120. And you don't have that information in that document. So how we are able to retrieve and answer questions if the actual answers are in related documents. So here is when a knowledge graph enters, because you are able to save those relationships, and in the vector DB you are able to save the content of those relationships, and with the two of them you are able to bring that complex structure into a retrieval AI. One interesting thing is that how you are able to maintain that logic, right? Because Seba, you're saying me that for me doing advanced retrieval finance, I need to create 3 databases. I need to have Databricks, I need to have a knowledge graph, and I also need to have a vector DB. How you are able to maintain all that in sync? So here is where Databricks writes, because he's going to be the one in charge or syncing the two words. So something that you are able to have in Databricks, because Delta tables, the ability of building a master knowledge graph table that mainly what does, it has the entity and the edges, and you are able to have this master knowledge graph table inside Databricks in sync with your knowledge graph. When you are parsing the information, you are able to save the metadata of that knowledge graph on Databricks and the actual relationship model into the knowledge graph. Here we are showing it with Neo4j. Neo4j is a knowledge graph tool, open source, that we recommend a lot because it's agnostic to the cloud and you are able to have it in your environment. Really good in this scenario. And at the same time, in Databricks, you are able to save the content with the chunking and collection identifier that have the relationship. So you're able to save that in Milbus. Between the two things, you are able to say, okay, when the retrieval agent needs to bring information, okay, so the retrieval is going to get information to be able to answer a question that the user does, he's able to go to Databricks, understand what I'm trying to bring, where in the knowledge graph are the entity of what I'm trying to bring and what is the relationship of it, and also where is the content of that information stored on the vector DB. And with all of that, instead of actually look for all the knowledge graph and look for all the vector DB, I use Databricks to pinpoint exactly where I'm looking the information and get it together to be able to retrieve that. I'm using 3 databases, but I'm saving time using Databricks as the main orchestrator to understand where to tackle each one of these things. At the same time, I'm able to leverage on the Unity Catalog of Databricks to control, okay, for example, maybe me, Sebastian, is able to access to data A, B, and C, but my boss is able to access to A, B, C, D, and E, and so on. So you're able to control the governance. You are able to orchestrate these workflows. You are able to do the CI/CD of it. You are able to create the observability using things like MLflow that are native to Databricks. You are able to control and create the evaluations of your agents without the need of an external evaluation tool like LangSmith or LangFuse. And lastly, if you want it, you are able also to provision the models, to provision the AI models inside Databricks. And obviously, maybe you are already doing it with Bedrock or with Foundry in Azure, but the advantage of having everything on Databricks is that you also have all the monitoring in one place. You see that 75% of this solution is purely data foundation problem. This is something that we discovered on Qubika. We were expending a lot of effort of enhancing the AI process, of getting better prompts, on getting prompt engineering, on getting better evaluations, of using better models, and so on. But we start discovering that actually the 75% of this game is play on the data foundation side. And if you're able to save and store and classify your data in a correct way, you are going to make much easier the work of the AI. And you are not going to need to expend so many resources on deploying big LLM models and so on in this part, because you are leveraging of a good structure of data. At the same time, you are reducing the amount of tokens, you are reducing the amount of infrastructure cost on the AI side, you are reducing the cost of maintenance. And the most important thing for me, at least, is that you also have already on Databricks, when you are building your data foundation side, you are going to already have all the part of evaluation, observability, monitoring, and so on, that it's always relegated when we are building an AI solution. Because remember, most people are building POC, but they are not building production-ready features. From the start, you are starting with a strong foundation. You are already preparing to be scaling this into a production level side. Interesting thing about LangGraph, you don't need to use LangGraph. You could use another framework for building agents. We prefer LangGraph for two reasons. First of all, because it's open source, so you're able to mount it whatever you want. But also at the same time, it's interesting because it's able to live inside Databricks. And in that way, you are able to manage the compute of LangGraph and the code of LangGraph inside Databricks without leaving your platform. And here is where LangGraph starts appearing. So for a retrieval module, a retrieval solution, we use the same three modules that I think every retrieval needs to have. First of all, we have an interpretation module. So the interpretation module mainly what does is when a user asks something, you need to understand what that user is asking, like what that means in your business context. Remember that when we are building this type of solutions, we are trying to separate ourselves from generic AI solutions that are in the market or itself from ChatGPT, because they are really good tools, but they are not tools customized for your business. They are not tools that are going to understand the differences and what makes your business different. So this type of interpretation model, what does is understand, first of all, who is asking the question, what business context are you looking for, from where are you need to take that, do you have that data? Because maybe if you don't have that data, you are not going to answer with data. You are going to say, I don't know. For me, this is the best thing that GPT-5 add to the updates, the ability to say, I don't know. Right now, one of the biggest problems of AI is AI adoption. And these people that are going to use this solution, especially on finance, they need to have something that they are able to trust, to understand that the answer that they are receiving, it's good enough to be used on an actual process of finance. So, and remember, finance moves money. So each time they made a bad decision, it's going to be effect on the cost side. So if we are not able to deliver something that is that generate trust for them, that explains for where this came from, that is able to relate and express a grade of correctness, they are going to go back to Excel. They prefer to do it manually than actually use an AI, because at least manually they are able to control what they are delivering. So this interpretation model is the key one that is able to understand, okay, what he's asking. And if it's asking something that is not clear, okay, let's do it a question to the user to separate or disambiguate that first question. Also, there's something really important that we need to check when someone is asking something is, are we already talking something on the conversation, or this is something new? Because maybe the answer is already in the business, in the context of the conversation. The second part is a retrieval. The retrieval, we are going to go to the Milbus, to Databricks, to the GraphDB, and we are going to join everything doing a RAG, but also a graph RAG, to be able to answer the question that was generated. Well, something really important is that the question that I'm going to use to answer and retrieve, it's going to be augmented in the interpretation model, because the model was able to expand the question to a bigger and more complete input. And lastly, we have the validations. So for the validation, I'm going to take every output that I have, and we are going to use, in this case, because we are using Databricks, MLflow, that is already a solution that lives inside Databricks, to build our metrics, to build our heuristics, our hard rules of the business, to build our LLMs that are going to work as a judge, and to also integrate the human in the loop to understand if the answer makes sense or not. With all of that, we are going to rank the answer, and depending if the confidence is high enough, we are going to give it to the final user, or we are going to go back and iterate the process. So I think the important thing in all of this is that there are not shortcuts to be able to address AI finance problems. You need to be able to, first of all, create solutions that behave as modules, and that you are able to inter-exchange and relate it between them, because AI is growing so fast that if you compromise with one solution, maybe your architecture could be outdated in the 3-4 next month. You also need to have a good observability implemented, because if not, you are guessing the answer and not actually giving a correct answer. You need to have a strong guardrails. You need to be able to understand what your answer, if it's correct or no. If this person, it's correct that he's asking for Python code in my finance agent, or this is outside the guardrails. Also, I will recommend to start using GraphDB to make a difference, to be able to reflect the relationships of our data and not only the content, because that is what is going to give meaning to our information, instead of only giving raw data without actual use. And lastly, if you expect to have a good AI solution with a good accuracy, and also that scales with your organization, you need to invest on a strong data foundation. As I mentioned previously, 75% of the solution is a good, strong data foundation. And tools like Databricks, Milbus, and Neo4j, obviously they are a technology, and you could say to me, hey, Seba, you are locking yourself in a technology. I would say yes. But at the same time, this architecture is built in a way that you could move it to another platform. You want to replace Databricks and use Snowflake? No problem. Instead of using Milbus, use ChromaDB? No problem. Instead of Neo4j, using Neptune. And at the same time, Databricks, Neo4j, and Milbus, they are cloud agnostic. So you are able to deploy this on AWS, on Azure, on GCP without any problem. Really have a robust architecture that thinks the problem in a bigger picture than actual a POC, but you are flexible enough to adapt to the changes of the market and the technology. This was the thing that we wanted to present to all of you. If there's any question on the public, I will lovely answer it. What are some of the metrics to figure out if the context is correctly retrieved? We have multiple metrics: correctness, accuracy, relevance. There are some metrics that are the common package on evaluating an LLM, but also you have some metrics that are more defined or customized for the actual business definition. So let's say that maybe the AI solution answers something that makes sense, but actually in your business doesn't. I always put this example. Let's say that I'm answer something about utilization. So I'm going to answer, okay, the utilization of my marketing area is 80%. Okay, but what was the formula of utilization? Not, he used the standard formula to calculate utilization. But maybe in your company, you have something more predefined. You use some variations to define utilization. So you also need to use those custom evaluations to see that makes sense with your business. And lastly, having LLMs that are able to evaluate each part of it and work as a judge makes a difference. What strategies are recommended for handling high volumes of data classification to avoid overloading the agent when processing incoming data? So something really interesting on Databricks, and because you're building on top of Databricks, it has an auto balancer that is able to scale, and it's able to handle it and duplicate and expand the amount of nodes to solve multiple queries at the same time. Also, because instead of sending big chunks of information, you are sending pinpoints of info that it's related, most related of what you're looking, you are reducing a lot the noise that you are sending, and that makes more faster. What is the advantage of using Neo4j and Milvus together with Databricks compared to a 100% cloud native alternative? I think in these cases, mainly the advantage that I see is that you could replace Milvus and Neo4j for Neptune and S3 bucket, and instead of using Databricks, use Redshift. The problem is that right now on the AI side, we need to be a little more agnostic. Many AI solutions are using services from multi-clouds, and Neo4j, Milvus, and Databricks give you the flexibility that if tomorrow you want to move, you are able to do it. Also, Milvus and Neo4j, there are tools that are more on the top tier than the ones that right now the clouds are able to provide. So obviously, using cloud native, it's more focused if you are in the AWS shop, but at the same time, you are locking yourself on the velocity on how AWS maintain these solutions. And sometimes what could happen, especially with the free cloud providers, hyperscalers, is that sometimes they deprecate services that you put all your trust on it, and that lets you constantly being changing everything. So my recommendation for AI will be to be a little more agnostic from cloud providers. Could this architecture shown in Databricks also be implemented on Snowflake? Yes, you are able to do it. You are going to need a governance tool. I think one of the big advantages of Databricks versus Snowflake is the Unity Catalog thing, especially because it integrates all the governance side in one place. And this governance called catalog, you are able to share it with other tools or take it from other tools. So that makes it easier and faster to process all this. If you are going to use Snowflake, there's no problem, but you are going to need to solve the governance side with other tools. If you had to start tomorrow in a financial institution with zero Databricks infrastructure, what would you recommend as the first step to reach this kind of architecture? So mainly what I would recommend is to start with a strong data foundation. First of all, do a good analysis of what you are planning to ingest and what you want to answer. And with this, start building from scratch this bronze layer. It's really difficult when you have your information living everywhere. My recommendation is start centralizing the information. That's going to make it much easier to implement AI. And after that, start putting silver, gold, and so on, and the parsing and doing more complex things. Do you know any example articles of good way for setting and managing a graph tile database for LLM retrievals? Yes, Neo4j has an amazing documentation for this. Also, there are some libraries on how to parse embeddings in the best way into graph DBs, but Neo4j is really strong. Right now, on removing from the cloud providers, I will recommend Neo4j and Nebula as the best graph DBs to use. And in the vector DB side, in our opinion, Milvus right now is the best. ChromaDB and Pinecone are really good, but I think Milbus has the best balance to offer. What role does Unity Catalog play in the validation and traceability of the pipeline? So the Unity Catalog is something that you are able to give to the actual retrieval and validation model to use to see, for example, if it makes sense or not that the user that is asking the question is accessing to the data that you are going to answer. So it's like a final check that you are not going to be giving data that you shouldn't be given to that user. And lastly, the Unity Catalog also lets you get a traceability of everything that enters on Databricks and what were the state of it. So you're able to show to an audit what was the data that you ingest, how you process it, how you tag it, how you move it, what you move to a knowledge graph, what you move to Milbus. And in that way, you are able to be really compliant with the different policies that are right now, for example, on finance. Neo4j supports embeddings. What are the advantages of also using Milbus? That's a good question. We are always trying to define that. For example, on Databricks, you also have vector search index, and people say, hey, if I have vector search, why am I going to use an actual vector DB? You need to use a tool that is really excelling on that. If you use Neo4j, that is an amazing GraphDB, also for semantic search, you're starting to corrupt the original purpose of that technology. And also, for example, in my opinion, one of the cons of a GraphDB is that they are slow versus Milbus, a semantic search that is incredibly fast. So I will recommend to leave the relationships only to Neo4j and leave the content that sometimes it's 200, 500 pages or more of information to Milbus. In that way, you are able to use the best of the two things instead of trying to solve all the problems with one tool. That will be my recommendation. But it's true that Neo4j supports the embedding side. With all of this, I think we are going to close. Again, thank you so much for assisting this presentation, and I wish you a nice day.